Hello and welcome to this video on Ohm's law, which is part of the electricity topic in GCSE AQA physics. So if we've been successful and we've learned in today's lesson, we should be able to understand the definition of resistance, construct an electrical circuit and measure electrical quantities, and define and use Ohm's law to calculate resistance. So we're going to look into the following part of the AQA GCSE physics specification: 4.2.1.3 current, resistance and potential difference, and 4.2.1.4 resistors. Now, when free electrons or any charged particles move around a circuit, they will hit the metal ions of the wire. This slows down the free electrons moving and lowers the current going through the wire. This effect is called resistance. So fundamentally, the electrons knock into the metal ions and slow them down, lowering the current, giving us resistance. Now, the more the free electrons that are restricted from flowing, the greater the resistance. Now, there are many different ways to do this, like increase the number of metal ions, make the metal ions vibrate with a greater amplitude, or decrease the space between the metal ions. Now, when electrons move to create a current, they must push their way past lots of vibrating ions which make up the wire. The ions resist the electrons moving as they collide with them. This is resistance, and resistance is measured in ohms. We're now going to look at how to calculate resistance in an electrical circuit. This was first found by the famous physicist George Ohm, so it's called Ohm's law. So George Ohm realised what the concept of resistance was. Resistance is the difficulty charged particles have when they try to flow in a current. Resistance is caused by the collisions between charged particles and metal ions in an electrical wire, and is calculated with the following equation: resistance is equal to potential difference divided by current. And we've named the unit of resistance after George Ohm, so resistance is measured in ohms. Now, when an object has a constant resistance, current and potential difference are directly proportional. Now, directly proportional means that the two factors change with the same rate. So, for example, when one doubles, the other doubles as well. Now, when this happens, we say that our device obeys Ohm's law. We say it is an ohmic component. Now, constant resistance can only be achieved when a constant temperature is gained on the wire, as temperature affects how many collisions occur every second. So we say Ohm's law can only be achieved if the device has a constant temperature. So we calculate resistance with the equation resistance in ohms is equal to potential difference in volts over current in amps. And any component which follows Ohm's law is called an ohmic component. So for example, a 10-volt bulb has a 2 amp of current going through it. What is the resistance of the bulb? Well, resistance is potential difference divided by current, so it's 10 volts over 2 amps. The answer is 5 ohms. Now we can calculate resistance experimentally by the following method. Stage 1. An ammeter is placed in series with the object and is used to measure the current through the resistor. Step 2. The voltmeter is used to measure the potential difference across the object. This is placed in parallel with the object being measured. Step 3. The variable resistor is used to adjust the current and potential difference. To investigate the variation of current with potential difference, the variable resistor is adjusted in predetermined steps. In each step, the current and potential difference are recorded from the voltmeter and ammeter. The measurements can then be plotted onto a graph. So the measurements of potential difference in current can give the following graph. The gradient of this line is the resistance of our circuit. This must have a y-intercept of 0, as with no potential difference, no current will flow. So a straight line through the origin shows a directly proportional relationship. In this instance, current and potential difference are directly proportional. Now, if the line is not straight and going through the origin, the material does not follow Ohm's law. So this graph allows us to work out the resistance of a resistor. So we know the higher the gradient, the higher the resistance. The lower the gradient, the lower the resistance. And a straight line gives a constant gradient, so the resistance of the material is constant. Now, what do we use to measure potential difference and current in these circuits? Well, a voltmeter measures the potential difference or the voltage, whilst the ammeter measures the current. So we measure current with an ammeter. An ammeter is a measuring device with theoretically no resistance and is placed in series in a circuit. We measure potential difference with a voltmeter. A voltmeter, a measuring device with theoretically infinite resistance, is placed in parallel with the device being measured. Voltmeter in parallel, VIP. So this is an ammeter placed in series in the circuit. This allows it to measure the flow of electrons in the circuit. Only one point is needed in a circuit to measure how quickly the electrons are flowing. This means ammeters can be placed in a series formation. Ammeters have a low resistance, as this doesn't affect the current flow it is measuring. The voltmeter is placed in parallel in an electrical circuit. The voltmeter measures the energy difference over 2 points of the circuit per charge, so it needs to be in parallel. The difference of the energy per charge measured before and the energy per charge measured afterwards allows you to calculate your potential difference. So this means voltmeters can be placed in a parallel formation in the circuit, but it must be placed in parallel with the device you are measuring, not any other part of the circuit. Now, a voltmeter has a high resistance, so it doesn't affect the current flow of the circuit. So, to clarify, an ammeter is placed in series with the component as it has a low resistance and doesn't affect the current flow in this way, whilst a voltmeter is placed in parallel as it has a high resistance, so it doesn't affect the current flow of the circuit. So to summarise what we've looked at in today's lesson, the current through a component depends on both the resistance of the component and the potential difference across the component. The greater the resistance of the component, the smaller the current for a given potential difference across the component. V equals IR. And students should be able to explain that for some resistors, the value of R remains constant, but in others it can change as current changes. The current through an ohmic conductor at constant temperature is directly proportional to the potential difference across the resistor. This means the resistance remains constant as the current changes. So if we've been successful and we've learnt in today's lesson, we'll be able to understand the definition of resistance, construct an electrical circuit and measure electrical quantities, and define and use Ohm's law to calculate resistance. So thank you so much for watching this lesson on Ohm's law, which is part of circuit electricity in AQA GCSE Physics.